All right, guys. Hi, this is Mr. H back. I have hopefully a quick video that I wanted to do for finding the probability of compound events. And I am going to, I'm just going to jump into this. Let's see, where am I starting? All right. So hopefully you can see my iPad. Before we start with finding the probability of compound events, I need to define a couple of terms that are really important. Independent events versus dependent events, right? So independent events means that the probability for one event doesn't affect the probability of the other event, or the first event doesn't affect the second event doesn't affect the first event, means they're pretty much independent, right? Dependent means that the one event is going to impact the second event. So they're kind of tied together. One affects the other. So in this case, the probability will change because of what happened in the first event. So independent means that the events don't affect each other. It also means that the probability for each event is, it doesn't change. Dependent events means that the probability of one is going to affect the probability of the second. So what happens in the first event is going to affect what happens in the second event, and it changes the probability for the second event. That's the key. If the probability changes because of what happened in the first event, then they are not independent, they are dependent, right? Okay, give you an example. Here we go. All right, here I have two coins. Let me put that back up. I have a nickel, it has a heads and a tails, heads, tails, and then I have a dime. It also has a heads and a tail. All right, so now, if I were to flip this coin, I would have a 50% chance of getting heads, right? Because there's two possibilities and one of them is heads. So I'd have a 50% chance of getting a heads. Now, if I go and I get my dime and I flip that, I also have a 50% chance of getting heads on that flip of the dime. The one event, the nickel, flipping the nickel, if I'd gotten tails, if I get heads, it doesn't affect what happens with the dime. So those two events, flipping the nickel, flipping the dime, are considered independent. And the probability of what I get on the nickel doesn't affect what I get on the dime. So they're independent. All right, first, second. Now, here's an example of a dependent event. Now, you're gonna have to work with me because I don't have another picture of marbles. Let's say we have this bag of marbles. You can see it has all these marbles in here. I used to be a pretty good marble player when I was young. I was really good. But anyway, so let's say we have this bag. Let's say the bag is not see-through like this. It's not a mesh bag. It's actually a opaque bag, so you can't see the marbles. So if I ask you to reach in and grab one marble, we could say, what's the probability of it being blue, right? And the way that you would figure that out is you would figure out the total number of marbles. Then you'd figure out how many of them are blue. That would be your probability of choosing blue, okay? So that's the first event. I say, reach in, grab a marble, let's see what the probability of getting blue is. So you reach into the marble or to the bag, you pull out a marble, and then you open your hand and we say, oh, you got a blue one. Now, you do not put that marble back into the bag, okay? So then I take the bag again and I shake it up without that marble because we took it out. And then I say, reach in again and see if you can pull out another blue marble, right? Now, on the second draw, the probability is going to be different because you've taken one marble out. In fact, you took one of the blue marbles out. So the probability of getting blue is going to change. So what happened in the first event affected what happened, the probability for the second event. If those two probabilities are connected, if one affects the other, then those events are dependent. They're not independent. They are dependent. See the difference? All right, now let's do a couple examples. This is from IXL. So now for these problems, we're assuming independence of the events, not dependence, but independence. So it says, what's the probability of flipping a tail on the first coin and a heads on the second coin? So on the first coin, we have a penny. So what's the probability of getting a tails? Oh, that's 1/2, because there's two choices, two possibilities, and one of them is tails, so it's 1/2. And then it says, what's the probability of getting a heads on the second coin, on the nickel? Oh, that's also going to be 1/2, because there's two choices and only one of them is heads. So then what you're going to do, because we are doing a compound probability, it has an and statement. And implies multiplication. So that's what we're going to do. We're going to multiply these. So 1/2 times 1/2 is 1/4. That would be our answer. That's what you're going to put in there. Simple. All right, next one. Now, look at this. We have two dice. We have two dice. One is green and one is red. So what they're saying is, what is the probability of rolling a 2 on the first die and a 2 on the second die? Now, these two dice are independent. So when I roll 1, it doesn't affect what happens on the second. They're independent. So what's the probability of getting a 2 on the first die? Well, there's 6 numbers. There's 6 faces of a regular die, and there's 6 numbers, and only one of them is 2. So it's going to be 1 out of 6. Actually, let's make this green. So this will be, the first one will be 1 out of 6. And then the probability of getting a 2 on the second one is also going to be 1 out of 6, because they're independent. And what happened before doesn't affect what happens on the second one. So then we're doing rolling 2, and that implies multiplication. So 1/6 times 1/6. Going to be 1/36. That would be your probability of rolling a 2 on the first die and a 2 on the second die. Got it? All right. Assuming independence. Let's do another one. All right. It says, what's the probability of picking a blue marble and then rolling a 5? Now, you should know that these two events don't really impact each other. Picking a marble is different from rolling a dice. So those two things don't really impact each other. It doesn't change the probabilities of each one of those events, okay? So these two events are independent. I put a little line here. Let me go back and make sure that's clear. I put a little line between the coins to indicate that those are separate events. Event 1, event 2. Event 1, event 2. First die is event 1, second die is event 2. The events here is the marbles are one event, and then the die is the second event. So what's the probability of getting a blue marble? Well, there's 3 blue marbles. How many total do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it'll be 3 over 12. We have 12 marbles, 3 of them are blue. And then we're going to do the die. It says, what's the probability of rolling a 5? We're rolling a 5. It's going to be 1 out of 6. And then all you're going to do is multiply these. We got an and, implies multiplication, going to be 3 over 18. That's going to be our answer. All right, so that's it, guys. That's all we're doing this week. Probability of compound events. We are assuming that the events are independent, right? Independent event means that the probability of the first event doesn't affect the probability of the second event. That's it. Simple, knock them out. Have questions, text me or send me an email. I love you guys, miss you guys. See you later. All right, that's it.